So we've learned that the law of sines is a great way to solve sides and angles of non-right angled triangles. However, there are instances where we can run into a bit of an issue with the law of sines, and it's on one particular type of triangle, and that's going to be a side-side angle triangle. So whenever you are solving triangles using the law of sines, you have to look for side-side angle triangles, because this can lead to what we call an ambiguous case. It could possibly give you 0 solutions. It might give you 1 solution, which is what we are used to with solving the law of sines, or there's a possibility that you could wind up with 2 triangles from the given information. So today we're going to look at an instance where you would wind up with 2 triangles from the given information that we have. So we have angle A is going to equal 40 degrees, side A is going to equal 12, and side B is going to equal 14. So I'm just going to go ahead and draw this up so it's easy for me to get a visual. So we're going to draw a triangle. It doesn't have to be the scale, because we're going to label it so that we know what goes with what. So I have triangle ABC here. All right, so I know that side A is going to be 12, side B is going to be 14, and then my angle A here is 40 degrees. All right, so for the law of sines to work, we need to have a matching set, which we do. We have 40 and 12, so then we can solve for angle B using the law of sines. So I'm going to set it up. This would be the sine of 40 over 12, and that's going to equal to the sine of B over 14. Now, we would multiply both sides by 14. So if we punch this in our calculator, you're going to get the sine of 40 divided by 12, which will give you a decimal 0.05. You multiply that times 14. It's going to give you 0.7499, so we would need to take the arc sine, the inverse of that, and that gives us 48.6. So angle B is going to equal 48.6 degrees. All right, so now, since this is a side-side angle triangle, we were given 2 sides and an angle that was not between them. We need to stop and see if there's a possibility that there could be another triangle. And the way we do this is we take this angle that we just found, so 48.6, and we're going to subtract it from 180. So 180 minus 48.6. So if you plug this into your calculator, you're going to get 131.4. All right, so the way to determine if there is a second triangle is we take this number and we add our original angle that we were given, 40, back to it. So if we add 40, we're going to wind up with 171.4. Now, if this value is less than 180, which it is in this situation, there are going to be 2 triangles. Okay, this number here that we got is our new angle B. So 131.4 is going to be angle B in my second triangle. When I subtracted this 48.6, this gave us the 131.4, which makes it our new angle B. So now what I'm just going to do is I'm going to slide this up so we can take a look. I'm going to draw a second triangle. Again, I'm not worried about drawing it to scale because we're going to label it A, B, C. All right, all of your original information, A equals 40 degrees, side A equals 12, side B equals 14, all of that is going to stay. Okay, so none of that information changes. All right, and now we have our new angle B. It's going to be 131.4, so I want to go ahead and fill that in. All right, so now we just want to solve for our remaining angles and sides. Okay, it's very easy to solve for angle C on both triangles. We're just going to take 180 and subtract our 2 angles. So for instance, on my first triangle, I would subtract 40 from 180 and then 48.6, and that's going to give me 91.4 for angle C. All right. So then on my second triangle, I subtract 131.4 and 40 from 180, and that's going to give me 8.6 degrees for angle C on my second triangle. So now for both, we'd want to go ahead and solve for side C. All right, so on my first triangle, I could set this up. You're just going to use the law of sines. So C over the sine of 91.4, and that's going to equal 12 over the sine of 40. So if you take that in your calculator and you solve, you get that side C is 18.66 for our first triangle. Okay, and so now we want to solve for C on my second triangle. So I'm going to say C over the sine of 8.6 is going to equal 12 over the sine of 40. And if we solve, multiply both sides by the sine of 8.6, we get that C is going to equal 2.79. So this is an instance where the law of sines might lead you to having two solutions, since this was a side-side angle triangle. I'll release a video here in the next little bit of an instance or two where you might not have any triangle at all, and how that you can watch out for that, and in some cases how you can determine that without doing any work whatsoever. So thank you guys for watching, and we'll catch you next time.